So just a quick review about the quadratic function. So its graph looks like this. So there's opening, this one is opening up, this one is opens down, and they're symmetrical about this called axis of symmetry, and left to right, and there's a vertex. When the opening is up, the vertex represents the minimum of the y, and if the opens is down, so we have a maximum point at the vertex. And of course, if the function, the graph could intersect with x-axis, and then it depends on what kind of situation. Right now it doesn't have any x-intercepts, but if you move the graph down, so if they just touch with the vertex, then we have one x-intercept, and then y is always going to have one. So if you extend this, you're going to see there's y-intercept. But if you continue to move this down, and we should have two x-intercepts. Okay, so now let's look at this example. So we're asked to graph this quadratic function. First of all, let's try to find out the x-intercepts. Of course, the graph is already done here. You can take a look at. So the graph is actually has an opening down, and this is the axis of symmetry, and then this is actually the two x-intercepts. Now if we can find out the two x-intercepts first, and then we should be able to locate the axis of symmetry, because this line of symmetry is actually in between the middle of these 2 points. Okay, so to find out the x-intercepts, we can simply make the y equals 0. So we turn this quadratic function into this quadratic equation. And then this is something we already know how to do, like we learned in last unit. So what I did is I divided by -2 to simplify this equation. So then I got 0 equals x squared plus 3x minus 10, and then I do the factoring, and then I got to solve the roots. One is x equals 2, then the other one is -5. And then I just plot these 2 points, -5 and the 2 as x-intercepts. Then I figure out and find out the midpoint, right? So the midpoint is supposed to be done this way. So we add the 2x coordinates, divide by 2, and then add the 2y coordinate, which both are 0, and then you should get -1.5 and 0 as this midpoint. We don't really need the midpoint. What we need is the x coordinate of this midpoint. So the -1.5, it becomes the line, the axis of symmetry. So the equation is x equals -1.5. So actually we drew this axis of symmetry, and then we figure out, oh, the vertex must be on this axis of symmetry. So then we use -1.5, plug into the original function to find out that y equals 24.5. Okay, then we got this vertex, the coordinate -1.5, and 24.5 is the vertex. Okay, so that's the vertex. And then to find out the y-intercept, so we can just simply plug in x equals 0 into the original function. So x equals 0, this is 0, 0, and then we got 20 left. So 0, 20 is y-intercept. And then we just have a look. We got x and y-intercepts. We got the coordinates of the vertex, and we got the equation of the axis of symmetry, and then look at the domain. So for this kind of quadratic function, its graph is a parabola, and you can see the x can be any real numbers. So that's the domain. And for y, because it has an opening, in this case it's opening down, so there's a vertex as a maximum point. So for the y value, it can only be 24.5 and smaller. So we got this range right here. Okay, and finally, just a note, the -5 and the 2 are the roots or solutions to this quadratic equation, but the -5 and the 2, they are called zeros of this quadratic function. See, the big difference is roots of solution is in terms of the equation. So there, in this equation, there's only one variable, which is x. Then zeros is for a function, so we have two variables, x and y. So why they are called zeros? Because these are the two x values that make y equals 0.